We have used fractions to represent leftover pieces from division problems. Basically, it shows us how close we are to making another full grouping. There's a concept here known as proportional reasoning. This is best illustrated by drawing a bunch of pictures of fractions. Notice that each fraction is represented by a different picture, but there's a real sense in which all the pictures are still the same. They all have half the circle shaded in, so that they're all halfway to a complete grouping. These pictures suggest to us that it makes sense for us to say 1/2 equals 4/8. We can show this using a technique that we used for division with many zeros. We're going to reorganize the wedges into groups of the same size. However, when we do this, we need to make sure that we do not mix the shaded and unshaded wedges. In order to follow this process clearly, we're going to use some computer-generated pictures, as they're far more accurate than what I can draw by hand. We will start off with a picture of 4/8. And if we break apart the shaded and unshaded pieces separately, we can see that there's one group of 4 shaded pieces and one group of 4 unshaded pieces. The 4 shaded pieces can be glued together into one piece, and the 4 unshaded pieces can be glued together into one piece. What's important here is that we're gluing the same number of pieces together in each part. After doing that, we can put the 2 parts together, and we see that we have 1/2. This is a graphical demonstration of what it means to reduce a fraction. This process is exactly the same thing we did with grids in the section on division with many zeros. We created clusters of 10 boxes and did division on the clusters of boxes instead of the individual boxes. Example, use parts of a whole to rewrite the fraction 8/12 in lowest terms. To write a fraction in lowest terms simply means to write it with the denominator as small as possible. In order to help visualize this, we will take the picture of 8/12 and draw out the wedges as individual pieces as opposed to being in a circle. So here we have 8 shaded wedges and 4 unshaded wedges. Our task is to pick the right size groupings so that 2 conditions are met. The first condition is that the groupings must contain the same number of wedges. The second condition is that shaded and unshaded wedges cannot be grouped together. The first task is accomplished by thinking about the divisors of 12. Creating groups of 1 isn't very helpful, so we'll skip that and start with groups of 2. If we take these wedges and put them into groups of 2, we will see that both conditions are met. Every group has 2 wedges, and we have not mixed together the shaded and unshaded wedges. This picture leaves us with the fraction 4/6. There are 4 groupings of shaded wedges, and there are 6 total groupings of wedges. The question at this point is whether we have created the fewest number of groupings. In order to know this, we have to try a few more. What if we tried groupings of 3? This won't work because we have a grouping that has a mixture of shaded and unshaded wedges. What about groupings of 4? We can see that this works and that this gives us the fraction 2/3 because there are 2 groups of shaded wedges out of 3 groups of wedges. There's one more divisor to try, which is 6. We can see that this has a grouping where shaded and unshaded wedges are mixed together. And so the fraction 8/12, when written in those terms, is 2/3. Students sometimes feel confused by this process because it's new and different to them. However, the ideas are not that complicated. We will show the same idea one more time with a different set of pictures to reiterate the point. We begin with a picture of 8/12, and by trying to make groupings of different numbers of wedges, we were able to find that groups of 4 wedges worked best. And so we took clusters of 4 wedges, all shaded or all unshaded, and glued them together to create new wedges that were bigger. And in the end, we had 3 wedges, 2 of which are shaded in. Just as we stepped away from the pictures when doing arithmetic with integers, we will now look to express these ideas using symbols. The process of writing a fraction in lowest terms is called reducing a fraction or simplifying the fraction. It turns out that the best number to use for the group size is the greatest common factor of the numerator and the denominator. In order to complete the calculation, we must introduce a new step known as canceling out a value. It's a simple idea that will be used throughout algebra. The idea is that if you have a fraction where the top and the bottom are written as products, and you see the same value appearing in both the top and the bottom, they can be crossed out without changing the value. This step corresponds to making groups of wedges. Example, completely reduce the fraction 8/12. We have left a picture here to help guide your thinking. What is the greatest common factor of 8 and 12? The greatest common factor of 8 and 12 is 4, So we will factor the numerator and the denominator using that value. 8 is 4 times 2, and 12 is 4 times 3. Notice that both the numerator and the denominator are written as products, and they both involve the number 4. This means that we can cancel them out. We indicate this by putting a line through the numbers. When we cancel out values, we basically pretend like they aren't even there. And so we see that the final answer is going to be 2/3. All of your calculations in this section should look like this. The equal signs are lined up, and the cancellation step is on its own line of work. Example, completely reduce to fraction 3/12. What is the greatest common factor of 3 and 12? It turns out that the greatest common factor of 3 and 12 is 3, so we will factor both the numerator and the denominator using that number. 3 is 3 times 1, and 12 is 3 times 4. Then we will cancel out the 3's and take a look at what's left. What's left is the fraction 1/4. If we sketch a picture of these two fractions, we can see that this equality makes sense. Both pictures have the same amount of circle shaded in. Example, completely reduce to fraction 30/100. Notice that you would not want to draw this picture. There are just far too many wedges for that to be realistic. However, it's not that hard to work with this algebraically. What is the greatest common factor of 30 and 100? We can see that 10 is the greatest common factor, so we will write this out as 10 times 3 over 10 times 10. And then the 10's in the numerator and denominator cancel out, leaving us with 3/10. All of these calculations are related to division problems. In fact, this calculation is exactly the same thing as saying 30 divided by 100 is equal to 3 divided by 10. We did this manipulation very often in the section on division with many zeros. And this helps to demonstrate the close connection between division and fractions.